Today on How It's Made. Handcuffs. Making them is a turnkey operation. Caulking and joint compound. We'll fill you in. Propane tanks. Containers that allow you to cook with gas. And forensic facial reconstruction. Putting a face on a mystery case. But first, the need for restraint goes back centuries. Handcuffs were originally a loose device until 1862, when adjustable ratchets were added. They allow the cuffs to snugly grip the suspect's wrists. When a crime is committed, a slap on the wrists usually isn't enough. It's time to handcuff them. When they put the handcuffs on, you know you're in a tight situation. Handcuffs start with a roll of steel. A machine pulls it through a straightener and then through a die that punches out a handcuff frame part. A revolving barrel cage sifts out the waste and kicks the frames into a bin. Here, a worker stacks U-shaped steel parts on a fixture, which he then clamps into a machine. A cutter makes ratchet teeth in the parts. Coolant keeps the tool from heating up and getting too soft to do the job. Each set of handcuffs will have 2 of these ratchets. Next, they load steel rods into a slowly revolving device. It moves the rods through a series of cutters. This is how they make swivels for the handcuffs. They round the tips of the rods and then carve necks below. This tool slices the swivel to the proper length. And then the partially finished swivel falls into a basket. Next, a drill works on the rounded tip, scooping out the center. And now you have a finished swivel. They take 2 chain links and 2 swivels. They make a small chain, 2 links with swivels on the ends. They lock the links and the swivels together. And now the swivel link assembly is complete. The swivels will provide some rotational freedom between the cuffs. If they don't weld the links together, the prisoner could have total freedom. It's time to assemble the handcuffs. They install studs in the outer framework and attach the ratchets to them. The swivel link fits into the little grooves in the framework. They hammer the inner frame on and then fit the top and bottom assemblies together. A tap with the hammer holds them loosely together. Then a press bears down to make a tight seal. These cuffs look complete, but they aren't quite ready for a life of crime. They need to be toughened up. So they spend 25 minutes in a furnace, and the searing heat hardens the steel. This is the pawl, a spring-loaded bar that will engage the teeth of the ratchet. They lock the pawl and spring in place. A press pushes pins into the assembly to hold everything in position. Then they stamp serial numbers onto each set of handcuffs so that the police can keep track of them. Now the handcuffs shake in a vibrating bin full of stones. This polishes the rough edges. It's time for the ultimate test. They activate a 500-pound pull. That's 228 kilograms in metric. And the handcuffs remain strong. They also tap each set to make sure the ratchets drop freely. Handcuffs are temporary restraints, and most can be opened with a universal key. They pack 2 with each set, along with the instructions. There's no doubt they'll have a captive market, because there's always someone who needs to be locked up. But then again, there are also those who deserve their freedom. The need to seal windows and cracks in walls and floors has been around since antiquity. Lucky for us, we no longer have to stuff rags or smelly fish glue into these crevices. Today's caulking and drywall compounds form durable synthetic seals that also blend into the decor. This company's caulking comes in 2 types, latex and acrylic. Both good for indoor and outdoor use. To make acrylic caulking, they blend water with chemicals that prevent mold and help the caulking withstand cold weather. Everything blends for about 1 minute. The batch then goes into another mixer containing 700 kilos of synthetic resin. They add a plasticizer that keeps the caulking flexible over time. A combination of colorants tints the caulking, in this case a shade of brown called sandalwood. After 15 minutes of blending, the caulking is ready. To test the batch, they cure a sample at 25 degrees Celsius for 1 week, then check its flexibility. If the batch gets the OK, it goes into this machine, which lines up plastic caulking tubes. Piston pumps lift 4 tubes at a time, and the nozzles fill each tube with 300 millilitres of caulking. The machine can fill up to 1,000 tubes every hour. The machine then seals the bottom end of the tubes with plastic covers. The top ends have closed nozzles with replaceable caps. Thanks to the resins and plasticizers, this company's products can last up to 30 years. That's the tough side of caulking, but there's also a gentler, craftier side. Start by drawing a pattern on a piece of paper, then lay glass on top and run caulking along the pattern. After 48 hours, the caulking hardens into a delicate lattice. Then fill in the spaces with clear silicone for a frosted look. Use a small steel brush and rubber gloves to spread it and create texture. Perfect for a door or bathroom window. This factory also makes joint compound. You use this product to cover cracks, holes and seams in dry wall. To make it, they mix 700 litres of water with chemicals that prevent mould, and a type of clay that makes the compound more spreadable. Now time for the main ingredient, 2,000 kilos of chalk. It's what remains on the wall when the compound dries. Next, they add mica, a mineral whose tiny plates slide over each other to make the compound flexible and help prevent cracking. They test the thickness with a device that gauges how much pressure it takes to stir the compound. Next, they take a sample from every batch and measure the pH level. It should have a reading of 8.8, quite high because of the chalk. This is what's called a sandability test. Technicians first let a precise amount of compound harden on a piece of dry wall. This machine then sands it down, applying 100 strokes in 2 minutes. Technicians then remeasure the combined weight of the compound and dry wall, registering how much has been lost. Maximum weight loss should be 4%. If the batch passes the test, they feed it to this machine. It pumps compound into either small size 3 kilo or large size 7 kilo plastic buckets. Then, using a hydraulic press, a worker seals the containers with plastic covers. To open the bucket, you break a small plastic tab and lift the cover. Joint compound also has its crafty uses. With a stencil, you can apply small amounts in intricate patterns to decorate a picture frame or mirror. Now that is some fancy filler. Coming up on how it's made. Propane tanks. This one's a real gas. And forensic facial reconstruction. A facial with a difference. Looking good. Bottling energy means you can always have fuel on hand. To make these tanks, they start with a big coil of steel. A press punches out 3 discs 50 centimeters in diameter in each swoop. A second press clamps the discs as a cylinder-shaped die thrusts upward, transforming it into a shell. Each shell is 1/2 of a barbecue tank. Next, suctioning devices carry the tank shells over to a trimmer, where a blade gives it a neat edge. Workers then insert flanges into pre-punched holes in the top shells. The top and bottom halves of the tanks now move in separate directions. The tops head into an automated welding station where the flanges are fused to them. The weld has to be perfect so it can take the pressure of compressed fuel without exploding. This die simultaneously bends steel strips into rings and punches holes in them. These rings will be used as pedestals, and the holes can be used to mount the tank to a barbecue. Next, a machine welds the rings to the bottoms of the tank shells. The top and bottom tank shells converge. And a pusher device nudges the tops onto the bottoms. They load each freshly assembled tank onto a welding lathe. The lathe turns as an automated welding gun follows the seam precisely, melting and bonding the 2 pieces together. But this processing has hardened the steel. Not a good thing, because these tanks will need to expand and contract to accommodate pressurized fuel. So they temper the tanks in a furnace. They do random tests of the welded seam. They cut out a piece of the tank and grind it on both sides to expose the weld. Then they use a jack to bend the sample right at the seam. If it doesn't split, it passes the test. In another test, they lower a tank into a water-filled drum. They pump water into the tank, causing pressure inside the drum to rise, proving the tank will expand with pressure changes. The tanks then travel down a row of paint guns, which spray them with electrostatically charged powder paint. The tanks journey over 3/4 of a kilometre to an inspection station. Here, workers check for contaminants. Then they drop valves into the flanged openings. and place the cylinders in a special machine that screws the valves on tightly. In one final test, they submerge air-filled tanks in water. If the water doesn't bubble up, it means the valve isn't leaking. And after all that, these barbecue tanks should be able to take plenty of grilling. When the usual ways of identifying human remains fail and the investigation stalls, police sometimes need a little image building. Using the skull, they recreate the face of the deceased in the hope that it will jog someone's memory. Talk about giving the case a whole new profile. To reconstruct a face, the specialist uses resin to make an exact replica of the unidentified man's cranium. He attaches it to the rest of the skull cast. And now he has an exact copy of the man's skull. Next, he measures rubber pegs to different lengths that are equivalent to the various thicknesses of facial skin. This short one is placed on the forehead, where the skin is thin. Then he installs eyes made of plastic. Those are suction cups protruding from them. They help him to align the eyes. He shines a light into them to confirm that they're looking straight ahead. Next, he cuts out muscle shapes from rolled clay. This piece simulates the area around the mouth. The dead man's muscles have left tension marks on his skull. Those marks, combined with the knowledge of facial anatomy, help to decide where to build up muscle. He makes the face expressionless, because expressions are unique and impossible to extrapolate from a skull. Next, he sculpts muscle around the eyes. There are no clues about the actual shape of the man's eyes, so he gives them a generic look. The skull does divulge the length and width of the nose, as well as the location of the nostrils. Now the specialist builds up the smiling muscles, followed by the fat and salivary gland. He uses different colored clay so he can see them more clearly. He maps out a location for the ears, but doesn't yet attach them. He shapes the muscles in the neck, working from measurements and photos from the crime scene. Next, he gives the model skin. As he applies this layer of clay, he uses the protruding pegs as thickness guides. And after much sculpting, the model has come to life. But he needs one more clay ear. The skull offers some hints about the ear's size, but not their shape, so he keeps that generic. Now, he sponges the clay to give it some texture, so it looks even more like real skin. Using a digital camera, the artist photographs the model and then downloads the image onto a computer. Using photo editing software, he transfers some hair to the shot of the clay model. He knows from evidence at the crime scene that the man's hair was styled in dreadlocks and that he had a beard. He borrows brows from another photo. He paints in the brows with a stylus. Using the same technique, he gives the image facial hair. And the skull mold and clay model alone takes 12 days to complete. Time well spent, because once the pictures and information are posted on police sites like this one, it may finally help them put a name to this face. So, whether you're a naughty fella caught in the act, or a DIY nut looking to fill a gap, or simply want to sizzle those bangers on a Barbie, now you know how it's made.